So hi to everyone, we are from the group 3 and we were going to discuss about the topic dynamic games with the complete information that apply the subperfect Nash equilibrium SPNE. So for our group, we doing the topic regarding bargaining games. So in this slideshow, basically we will include two topics which are the ultimate game and also finite horizon bargaining. So actually, what is the ultimate games? Ultimate games actually is the simplest form of bargaining. One party make an offer and the other party either accept or reject the offer. For the player 2, it has no more future negotiation with the player 1. It means that the stage of the time is only 1. So to be easy, we can look on this picture. So for example, player 1 got one pie and he decide to split the pie into s and 1 minus s. So player 1 will take the s1 and the 1 minus s part will split to the player 2. So player 2 will decide whether to reject the offer or accept the offer. If second party, or we call it as player 2, reject the offer, then the payoff will be 0 and 0. If second party or player 2 accept the offer, then the payoff will be s 1 minus s. And actually it's not the bargaining because second party or player 2 do not have bargaining power.
Now I'm going to explain to you primary sources of bargaining power and give some brief intuition as to why they can improve bargaining outcomes. Sources of bargaining power are as follows: proposal power, patient, outside option, knowledge of the other side's minimum value, until costly signal of higher value. So if we can do any of these things, or if we have any of these things, we are going to end up in a better place after the negotiation ends. Proposal power. Proposal power is the most critical than anything else in this list of source. Proposal power is the ability to make offers to the other sides. We are actually making and issuing the terms of settlement. In contrast, if your ability to only say yes or no to an agreement to accept or reject the offer, that is not good because you are not going to be either not any better off or only very slightly better off after the negotiation ends. Thus, if you have the exclusive ability to make offers to the other sides, then you are going to reap almost all of the benefits. Moving on, patience is also important. Let's say if I do not need to reach a deal, if I am not desperate to reach a deal, then I'm going to get a better deal. On the other hand, if I really need a deal to happen or I can't wait very long for this deal to be sealed, then I'm going to be in a very bad position, while the other side is going to take advantage of me as a result. This is sometimes called the tragedy of bargaining. Outside option is another important part in bargaining. If you and I are negotiating, but if negotiation fails between us, I can go to a third party and receive some sort of deal from that third party. In other words, if I have a competitive offer from that third party, that is going to force you to be nicer to me in our negotiated relationship. Because you don't want me to leave our bargain and try to bargain with this third party. Having the upside option, which is this third guy, forces you to give me concession, which is good for me. Related to that is monopoly power. Let us put simply, if I present something that is unique or unique ability that no one else can replace, this is going to result in me getting all the benefits of the economic relationship. Next, reputation. Reputation is important. If I have a reputation to protect, I will get a better deal. Now, let us see credible commitment. If you can willfully break an agreement, this can cause no agreement to occur even though both of us will be better off. If the agreement occurs and we actually follow through on it. In other words, negotiating a solution in a legally enforceable way ensures both parties to follow through on the agreement. As the saying goes, knowledge is power. It is simply means if you know the other side's bottom line, you are able to get deals closer to it. Finally, cost signaling. Signals that you are worth more can lead to better offers. Signaling the other side that you are worth is to be showing off to them that you are this really good, this powerful, really strong type. Now, let us move on to see what will happen if the second party has the bargaining power. Let us assume that second party now can make a counter proposal after reject the first party, where the finite horizon bargaining T is less than infinity. The discount factors are included, and so does the backward induction.
Okay, so next we will look at the Fogg theorems. So Fogg theorem says that since the patient is a source of bargaining of power, by these theorems, which say if the player are patient enough, so you can wait for longer, so the chance of getting discount will be higher, or in other words, which approach to 1. And these discount factors actually the variables in between of 0 to 1. So that's a small remark. The higher these discount factors mean the more patient it will be and higher chance that will survive the next stage. So machine the T is getting higher, and each stage the payoff matrix multiplied by the discount factors and sum of payoff basically is the form of geometries. So actually this is using the idea of backward inductions, which include here since it's a finite horizon game, which introduced by the group 1. So, and notice that this is actually a subgame, so with T2, so which is part of it. And the subgame is actually part of game which fulfill a few criteria. So it's still going to bring out by group 1. And we are especially looking at the case of T equals to 2. So because of T equals 2, we can actually use the backward inductions by the subgame perfect Nash equilibriums carried out by the group 1.
At the first stage of the game, player 1 will offer x1 and 1 minus x1. Then player 2 have two choices. If he accepts the offer, then player 1 will get x1 and player 2 will get 1 minus x1. If he rejects, then the game will enter the second stage. At the second stage, it is exactly the same as the ultimatum game, where player 2 offers x2, 1 minus x2, and player 1 chooses either to accept or to reject. In this case, if player 1 accepts the offer, then player 1 will get x2 and player 2 will get 1 minus x2. Otherwise, if player 1 rejects, then both players will get 0. And from the previous session, we know that the SPNE of the ultimatum game is that player 2 will offer 0 and 1, which will be accepted by player 1. So, given this situation, how will player 1 make the offer in the first stage to prevent the game from entering the second stage so that he will not get a payoff of 0? So, in fact, by backward induction, the unique SPNE of the game is player 1 offer 1 minus delta 2 in the first stage, where delta 2 is a discount factor of player 2. Then player 2 accepts any initial offer if her payoff is greater than delta 2, otherwise reject the offer. If player 2 rejects the player 1 offers, then player 2 offer 0 and 1 in the second stage. Then player 1 will accept all the offer proposed by player 2. So, in the figure, we can represent the SPNE in like this, and the table that we can write the SPNE is given like this.
Hi, I'm Yishan. Now we are going to discuss for the case of t equal to 3. Consider the following 3-stage bargaining game in which $1 is to be split between player 1 and player 2. Each player I has a discount factor delta I element of 0 to 1. In this case, we were to determine the subgame perfect equilibrium SPNE of this game. Case of t equal to 3 actually is an extending game from t equal to 2 by adding a stage t equal to 0 before t equal to 1. So in this case, player 1 will have two chances to offer the amount for player 2 to accept. In stage t equal to 0, player 1 can offer the amount 1 minus x now for player 2 to accept. If player 2 accept, then the payoff for player 1 and player 2 will be x now and 1 minus x now respectively. If player 2 reject, then they will proceed to stage 1. Player 1 can offer 1 minus x1 to player 2 in stage 1. If player 2 accept, then the payoff for player 1 will be x1 and the payoff for player 2 will be 1 minus x1. If player 2 reject, then they will proceed to stage 2. In this stage, player 2 is the one who offered the dollar to player 1. So player 1 will force to accept any amount that player 2 offer. Because if player 1 reject the offer, both of them will get the payoff of 0. Let's see if player in stage t equal to 0, player 2 will accept if and only if 1 minus x now is larger or equal to delta 2 squared. In stage 1, player 2 will accept if and only if 1 minus x1 is larger or equal to delta 2. In stage 2, player 1 will accept if and only if x2 is larger or equal than 0. Thus, the subgame perfect Nash equilibrium SPNE is as shown in the table. In stage 0, player 1 will place x now equal to 1 minus delta 2 squared for player 2 to accept the offer. If player 2 reject the offer, they will proceed to stage 1, where player 1 will place x1 equal to 1 minus delta 2 for player 2 to accept the offer. If player 2 still reject the offer, they will proceed to stage 2. In this stage, player 2 will be the one who offer the player 1 the amount of $. Player 2 will place x2 equal to 0 in order to maximize his payoff. In this stage, player 1 is forced to accept any x2 amount in order to maximize their payoff. Now I will pass the presentation to Haziq.
Therefore, iteratively, the payoff for the respective players in equilibrium will be as follows. For player 1, the payoff denoted by x1 is equal to the summation of 1 minus with discount factor of player 2 times with discount factor of player 1 discount factor of player 2 to the power of t. The summation of this from t equals to 0 to t over 2 minus 1. This can be simplified into 1 minus with discount factor for player 2 times with 1 minus with discount factor of player 1 discount factor of player 2 to the power of t over 2 divided with 1 minus discount factor for player 1 discount factor for player 2. For player 2, the payoff will be denoted by x2 is equal to 1 minus x1, which is the payoff for player 1. This can be simplified into discount factor of player 2 times with 1 minus with discount factor for player 2 minus with 1 minus with discount factor for player 2 times with discount factor for player 1 discount factor for player 2 to the power of t over 2 divided by 1 minus discount factor for player 1 discount factor for player 2.
Hello everyone, my name is Damien Jen. So as a conclusion, for the finite horizon bargaining, we can apply the backward induction to get our sub-perfect Nash equilibrium, or SPNE in short. But however, in the case of infinite horizon bargaining, the backward induction cannot be used anymore, and another model will be used, and that model is being called Rubinstein model, which we do not cover in our presentation. So here are my team members, 7 of them, namely Guan Qiufeng, Wei Guoyan, Tan Yixuan, Mi Timingjian, Eugene Leong Juntong, Wei Wei Sun, Muhammad Haziq. And that marks the end of our presentation. Thank you.